Hi, I'm Phil, and today we're going to look at the Elecfreaks IoT bit board for microbit. IoT stands for the Internet of Things, and we'll explore some of the projects I've done, particularly for water measurement. And this is what the board looks like in detail. It costs $16.90, and I got this last October, but I've just put it to current use at the moment. And you can see the resources on board. You've got a Wi-Fi that connects to the internet, and that's the reason why they call it the IoT bit. But it also has a real-time clock and battery backup for that clock. I have used the pins on the bottom here to connect to a BME280 to measure temperature, pressure, and humidity. And I've also got a potentiometer connected to port 2 of microbit, and port 1 has another sensor, an analog sensor, and we'll see how that's been used in a minute. So hardware-wise, this is what it looks like, and you plug the microbit into the blue socket that's shown near the middle of the board here. And it also has a buzzer on board. You've got access to all the pins. So software-wise, you can either use Makecode or Python. I'm using the extensions on Makecode, and simply type in IoT and the extensions come up on your Makecode window on a Chrome browser. So the projects I've been working on, I've been looking at home, connecting to our Wi-Fi network, and it goes on to a MQTT server. I've also tested the real-time clock, and I've made a couple of clocks with that. But for the preparation of Parramatta's IoT talk, I've been looking at using the kids' IoT network, and I've been looking at water quality with ORP, which stands for oxygen reduction potential. Also measuring water quality with pH, and I've still to do some projects with total dissolved solids and turbidity. We could also measure the water temperature and the water level. So let's have a look at the ORP project, see what it looks like. We'll just collapse all of these headings at the moment, and we'll look at what the objective is. So the desktop looks like this. So right on the top there, I've got a microbit, and it's sitting on the IoT bit board. Under that, we've got a 1602 LCD, and that's connected to a I2C port. On the bottom here, we've got a BME280, and next to that, we have an interface that allows our probe, which I'm holding with my hand here. It goes in via a connector to an interface board, and that goes into the microbit as an analog signal on port 1. And you can see the measurements over here on the LCD. We've got the temperature of 14, humidity 57, pressure 1014, and the ORP is 348. And there's the ORP probe. So that's what it looks like. And the objective was to show time, date, temperature, humidity, pressure, and ORP readings. Not only show those on an LCD screen, but transmit them to the Kids IoT website. And I want to keep the time going, so I could use this not only to transmit IoT data, but I could use it on a data logger with the hardware real-time clock timestamp. I'm using the microbit buttons A and B to increment the time parameter, and I select a time parameter with a combination of pressing A and B together. Hardware-wise, I'm using microbit version 2 and the Key Studio LCD 1602 to show the results. So I've got 2 lines there to show the results. The IoT bit from Elecfreaks and the Grove Studios ORP sensor kit. Software-wise, all of that's going into to Makecode, and you can see the full extent of the software now. And execution-wise, it went quite well, and we've been collecting the results for temperature, humidity, pressure, and ORP. And there's all of the results that I'm collecting at the moment. So if you're interested in this, go across to the website, the Seed Studio, Elecfreaks. And the other project I've been working on is the pH. And this is quite similar. We just changed the displays this time. So we're doing the same temperature, humidity, and pressure. All of that's been measured with the BME280. And you can see the arrangement on top. We've got the BME280 is same as we had last time, but we changed the display this time to a electronic display where you can see temperature on the top line, under that humidity, pressure, and the measurement of pH. That pH still has to be displayed as a pH between 0 and 14. And at the moment, it's just showing the analog to digital conversion number, the maximum being 1024. And as before, we transmit that to the kids network. And with this is the hardware that we're using this time. So, we'll see if we can get the results. So the results are came out quite well. And that's our water quality measurements using the microbit computer. In this arrangement, we're measuring the pH of an aqueous solution, like water, and we're using a pH probe, which is connected to an interface, and that goes to a microbit computer. So the microbit computer's on the top. It's connected to a electronic LCD that shows the various measurements, and we have a BME 280 measuring temperature, humidity, and pressure. And we have a potentiometer. This allows us to switch between the home Wi-Fi network and my mobile phone. So this whole arrangement is running on microbit with Makecode, and at the moment we're taking the measurements every 5 minutes, and once an hour we send the measurements to the kids IoT network. And you can see the measurements on the computer here. So the pH measurements are shown here. Here we have a oxygen reduction potential, or ORP probe, and it's used to measure the water quality, and the probe is being fed into an interface, and that interface goes into a microbit computer, and I'm using the Elecfreaks IoT board. I'm also measuring the temperature, humidity, and pressure of the air with the BME 280, so it's been measured in this module, and it also feeds in via the I2C port onto the microbit. And we have a LCD display, and it's currently showing the Wi-Fi connection, the date and the time. And it will switch across in a minute to the measurements. So every 30 seconds it shows time and date, and it will show the measurements in a minute. And here we are, we can see those now. We've got the temperature 15, humidity 70, the pressure 1021, and the ORP is 349. And we can switch, we can see those measurements on the Kids IoT network. If we look at all the measurements that I'm taking at the moment, ORP is number 9. So we'll just have a look at those, and so you can see the measurements here. And that's the ORP probe on the microbit computer.